Hello, welcome to another video from Berkshire Guitar Amplifier Repairs in a cold November, bleak Reading in Berkshire, England. It's currently 2021 for historical purposes, and on the bench I have this Fender Concert, which I have never had one of these before. It's a hulking great big beast of a combo. It's got 4 speakers in it. First one I've had in the workshop. The customer has had it in storage for many years, hasn't used it, the usual sort of thing, and he wants me to strip it down, check it out and get it back up to scratch. So I thought it would be quite an interesting video to take this chassis out and have a look and just kind of go through and see what needs doing, if anything. I don't think it's ever been revalved. I think the valves are original, so we may persuade him to have a new set of valves. Let's just take it to bits and have a look. Well, here's a quick look across the controls. It's in quite nice condition. It's a nice black face amp. This may be completely original inside, untouched, in which case we're going to have a look at smoothing caps and that sort of thing, HT caps. Anyway, let's have a little look around the back. These look like the 4 original 10-inch speakers for this. I can't see any evidence of them being changed. Reverb tank on the bottom, no idea if that works, and the standard kind of Fender lineup along the back here. Reverb and tremolo foot switch. That's a new one, line recording, haven't seen that before. Speaker output, and there we go, yeah. Presume there's a foot switch. Oh yes, here's the foot switch. I think what I'll probably do is just turn it on and see what's what. Okay, it's all connected up. I haven't turned it on yet, so let's turn it on. We have a light, which is always promising. I imagine the pots will be quite dirty. I can feel they're stuck in one position as I turn them, so they'll probably be quite bad, the pots. Right, let's try taking it out of standby. Sounds promising. Oh, it's working fine, great. Scratchy, scratchy, scratchy. Reverb? Good, reverb's working. That's good. Okay, it could be a 2-channel amp. A sort of 2 foot switches on the foot switch unit. One will obviously be for reverb, and I assumed the other one was standard tremolo, but this hasn't got tremolo, so is it a 2-channel amp? Where's the foot switch? Oh, okay, right, so interesting, okay. So look, it's a 2-channel foot switch, reverb of course. Let's see if that works. So reverb is up at the moment, and that kills it, that's good. And this should now, I assume, change it to this channel here, and indeed it does. Okay, that's good. Okay, so that's all working. So at the moment the pots are a bit scratchy. That's easily solved. I think we're going to take the chassis out and have a look at the HT caps and make sure that they are okay, or whether they need changing. Have just a general look over the underside of the chassis, and also think about maybe revalving if it's never been done. So the next thing I'm going to do is take the chassis out. Okay, chassis out, let's have a little look. First thing I notice is I don't like the look of these 2 valves, both 6L6 GCs, and this one doesn't look anything like that one. Probably a completely different make. So we have a motley selection of output valves. We definitely want to be changing those. It looks very clean along the top here, I'm not sure when these were made. If I had to guess, I'll look it up before the end of this video, but I'd guess 1970s rather than 1960s. The fact that it has those LEDs on the foot switch is a little bit of a giveaway. Now what have we got in the way of valves here? Right, yeah, kind of mixture really of old ones. That's a GE, that's something IC electronic, I never heard of those. Fender here, Fender. So again, there's a Marshall valve there. So again, a complete motley selection. I think I'm going to suggest a complete revalve here. Now then, the amount of work that we have to do, I haven't looked under the underside yet, is fairly dependent on this, what's under here. Because if those caps have been changed, we can probably be certain that the underside will be quite good too. So let's take this cover off and see what the HT caps are looking like. This screw here is not in properly, it's virtually hanging out. That was just about to fall out, that screw. Unfortunately they are originals. Okay, they are the original valves. They don't look too desperate, but yeah, these are the original Mallorys and have been in here, I don't know, 30 years or so. That one's got a bit of leakage on it, I think. They're not obviously leaking, so we could take a view on this, and there wasn't any hum on the output, so that implies that the HT caps are kind of doing their job. Let's flip it over and see what's gone on in this amp over the years. In a moment I'm going to look up how old it is. Ah, interesting, okay. Alrighty, so that's interesting. I've never seen one of these before. First for me, and I see thousands of amps. It's amazing how often I do see a new amp. Right, so I think these are probably originals, these orange drop caps. I don't get the feeling looking at these joints that they've been upgraded, so that makes this amp a little bit more recent than I'm maybe thinking. That's good, these are excellent capacitors. The resistors are carbon film, so that standard carbon composite, so that does date it, but they all look quite new. Very clean looking amp underneath this, isn't it? We have some electrolytics here, 25 microfarads at 25 volts here. These are almost certainly the cathode bypass caps for the first 3 stages. We have another electrolytic there, another one there. That's interesting. That looks for all the. That's an opto-isolator. That. What else? We're seeing another electrolytic there. All in all, a very clean example of this amp, almost mint actually. So this has been stored very well, well looked after. Oh, there's another opto there. Oh, there's another one there. Oh, gosh, there's opto-isolators all over the place. So I wonder why they're opto-isolating everything. Fascinating. No idea. We've got 1, 2, 3, 4 opto-isolators here. Might pull a schematic on this and see what they're up to. Anyway, there you go, a nice clean example. It won't take us long to clean the pots, obviously. So it's really a question of how much money the customer wants to spend on this one. We have some options to completely revalve it. I mean, the amp's basically working, so you could say, you know, just keep it as it is. So in price terms, we could say the cheapest option is to service it and put 2 new power valves in, which I do think needs doing. Next most expensive is a full revalve, which again would be nice. And then the third most expensive is change the HT caps and do the work we've just mentioned. And the fourth most expensive is do all that plus all these low voltage electrolytics. So it's really a question of what does the customer want to do with this amp. This is interesting here. These are, got a couple of diodes here, a little one there and one there. Now what's the rectification on this? It's not valve rectified. I can't see a bridge rectifier with 4 diodes, so and I also can't see the negative bias. Okay, right, we've got the 4 diodes here up in this little subboard here, so they're the HT diodes. That's fine. These will probably be the diodes for the negative bias voltage. But where the bias smoothing cap is, I don't know. I cannot see that at the moment. I would expect it to be around here. Smoothing the negative bias. Okay. I think I know what's going on. Right. So this is the negative bias control pot. I could tell that because from it comes the negative bias which goes to the 220k resistors which feed the screens of the output valves. There's a little trim resistor there to get the bias right, and the bias comes in on this tag here, which is interesting, here, and that goes to this rectification here. So in other words, negative bias coming in here, and I think it's being smoothed on this wire here, which disappears down the hole and probably goes into the dog kennel on the other side, and there'll be a smoothing capacitor there for the HT. So if we turn it over, we're looking for capacitor which isn't an HT cap, in other words, isn't 350 volts or something. Oh yes, look, we've got lots of capacitors up here. So one of these 70 microfarads at 100 volts. There you go. So that will be the smoothing capacitor for the negative bias voltage, and here are the HT caps. Another 70 microfarad at 100 volts there, that's interesting. 20 microfarads at 500, 220 microfarads at 285, 70 microfarads at 100 volts. I'd expect that just to be the negative bias cap, but we've got 2 more of them here. 20 microfarads at 500, 20 microfarads at 500. So these here are the HT caps. What these 3 are doing, I at the moment don't know, I'm afraid. So there you go. That's the look around. That's what needs doing. Now it's on to the customer to find out what they want to do in terms of spending money. Okay, I've had a word with the customer and he wants the works. So everything. We're going to change all these capacitors and all the valves, and do the electrolytics on the underside as well, and this amp will be good for a few years yet. Okay, the valves on this are ECC 83, 83, 81, 83, 83, 83, 81, or if you prefer 12AX7s and 12AT7s. So I think we'll just whack in a new set of JJs. This is a bit of a motley selection. This is a, you can hardly even read this. There's a fender valve there. Let's see what we've got in here as we take them out. This one is also a fender. This is a 12AT7 or ECC81, and this is a Pinnacle. It's an old valve, that. As I speak, where am I now? November 2021. It's very hard to get valves right now. They are in extreme short supply. A big Chinese factory burnt down 2 years ago. They haven't got around to rebuilding it, and everyone is really short of valves. A JJ have kind of fallen over. They can't
supply in anything like the quantities needed. The Americans, New Sensor, are in the same sort of predicament. They can't supply anything like the amount of valves wanted. JJ are supplying this is an electronic valve, never heard of that one. JJ are supplying the amplifier manufacturers, would be my guess, and leaving people like myself without any valves. They don't even answer the phones anymore, don't answer their emails, can't get anything out of them whatsoever. Distinctly unimpressed with JJ actually at the moment in terms of, service. This is another electronic. Never come across that make before. And finally this one here is a 12AT7. This one here. And what makes that? That's a Mazda. So we've got everything here. 1287. So I'm getting through my precious supply of valves, and the prices have gone up hugely, like 30% increases. Not that you can get the valves anyway. Okay, so that's all the preamp valves done. I'm going to do this, a step at a time. There's no point in blitzing an amp and then you turn it on and find it doesn't work. And you think, oh, right, well, what was it? Was it the power valves I put in? Was it the caps I changed? Was it the preamp valves? So I'm going to plug this in now and power it up again and just make sure it's working. Okay, that sounds okay. And you can change the channel by pulling this knob here. So now we're on this channel. All still scratchy. Haven't done the pots yet. So good, that's alright with the preamps, that's fantastic. Okay, we can put all these caps back on. Next thing I'm going to do is the power valves. What have we got in here? We've got a I can just about see an F or something on there. I think that may have been a, no, maybe I'm looking at a scratch. No, I don't know, I might say F there, might be F for fender, I don't know. This one, this is a GE ancient tube, some really old things, so these aren't anything, not even the same size, look, total junk. So we'll put in there a new pair of JJ6L6GCs. I'm going to put a bias meter on as well at this stage. I'll probably redo the bias because I'm going to be changing bias, smoothing capacitors and that sort of thing, so it makes sense to just double check the bias after I've done that, but I want to see if it's kind of vaguely in the right ballpark. Right, that's two new valves in, so we can plug in and make sure that works. Kind of step by step really is the way to do this. So there's the bias meter. And 462 plate volts, up comes the bias current. Look, I'm looking for 37 milliamps or something around about that kind of. I can immediately tell that's going to be not far off the sort of bias current we're looking for. And it sounds alright. Goody goody, don't need to bother about that at the moment. As I say, I'm going to be trimming the bias. Now oddly enough, the next thing I'm going to do is I've got these capacitors on order. I probably have quite a few of them, so I might make a start on putting them in. But I've ordered a complete set of that just to save using my stock. And this mains plug is going to have to come off here because this is now no longer up to date with the current regulations. The current regulations have a shroud, an insulated piece halfway up these pins here. I guess it's to stop people. Well, I think if you kind of grab the plug like this, and pull it out. I guess some people might have been touching these pins somehow, I don't know. Or, you know, what we used to do back in the day is, you know, wrap a bit of wire around there, wrap a bit of wire around there and take it off to another appliance. That's going back a long time. You almost certainly know this, but anyway, here's a new plug. Look, can you see those insulated sections there on the live and neutral? So this is what's approved these days. So I'm going to take that one off and put that one on there, and I will leave you whilst I do that. Okay, I've put the new plug top on, and I'm now going to put whatever caps I've got in here. I've certainly got the 20 microfarads at 500 volts. I've taken a photograph of that and also made a little map here, because you can see, look, you know, that positive is there, but that one's there. These positives are down, that positive is up, that positive is down, that positive is up, that positive is down. So there's a really good chance of making a mistake here and having that kaboom moment. So let's make a start. Well, since it's easy, we'll start with these two 20 microfarads, both of which are positive down. So we'll just cut these old ones out without any ceremony, and I normally leave a stalk here. I always put these to the side there just to remind me which way round they went, and this stalk here is very useful for attaching the other capacitors. It can be quite hard to get a new lead down into this eyelet board sometimes, in fact almost impossible at times. So we're going to put these 22 microfarads at 500 volts in here. So I think the first thing I'm going to do is to hot melt glue those in place, so that they big difference in size, isn't there? Look, over I don't know, we're looking at 40 years. So this is 20 microfarads at 500 volts, 22 microfarads at 500 volts. Massive difference, isn't there? This was built in the 80s, by the way, this amp, 82, 83. So it's, you know, not that old, but you know, the 80s seem kind of yesterday to me. But we're talking 40 years, you know, where does the time go? Anyway, let me get my hot melt glue gun and we'll tack those two in. With hot melt glue along the bottom basically is all I do. Trim the excess lead off. Just going to go in there. The hot melt glue, so it just stops it vibrating around, of course, that's the purpose of this. I like to try to get them nice and square, and always have the legend upright so that people can read off what they are. I hate to see capacitors put in upside down where you can't see anything. Right, that's that. So we'll do those two, I think. There we go. So I just bend this round here like this, and this one round here. It's all very well me saying, I'm sure you've seen me do this before, but of course I would think maybe 90% of people watching this video probably haven't seen many other videos, because people search on things like you know, distortion in Fender Blues Junior, and up comes my video dealing with the distortion in a Fender Blues Junior, but that doesn't mean to say they've seen any other of my videos. So I sort of, excuse me if you are a fan, if you know what I mean. I don't mean a fan, I mean if you're a long time watcher and you see me do the same thing over and over again, of course you can always just fast forward. There we go, so that's that. That's how you do it. And then I would normally trim off these bits here. Always grab the bit you're trimming off so it doesn't ping off into some remote corner where you don't find it, and it rattles around inside the amp somewhere and eventually causes some sort of short circuit. Positive down, positive down, positive down, positive down. Can't check often enough. Believe me, I've got it wrong. in the past. So that's those two done, which is good. Again, we'll just trim off this bit, and yeah, we'll trim off that bit. Yeah, they're probably okay, these caps, but they're 40 years old, and you would expect maybe 25 years out of an electrolytic capacitor, so they're well past the date where they need changing. 22 microfarad, positive downwards. This time I won't glue it on because it's on top of these resistors. So we want that to be about like that. So. Like so. You know, just needs basic soldering ability and a certain amount of mechanical skill, but certainly not rocket science. To solder, by the way, always put the iron on first. Feed the solder in, iron off. Don't go dabbing around now to try to make that any better, blobbing around. Don't do that. Iron on, solder in, solder out, iron out. That's the sequence. Okay, good. So let's just check we've got that one right. That's that fourth one, this one. Positive there, look. That's good. So that one's okay. Right, we're on a roll here. Now, do I have any... I've got a feeling I've got a couple of 220 microfarads. Let's have a look, see what I've got. Yes, as luck would have it, I do have my last two 220 microfarads at 300 volts, so slightly more voltage than that. That's okay. So we're going to pop those in now, which is good. We're doing well on this actually. Didn't expect to get quite so far with this today. So we'll chop these out. These can all go now. We'll put these here to remind us which way round they go. Again, a couple of 220k resistors. I think with a bit of luck, yes, we can measure those. These are balancing resistors. These two capacitors here are in series with each other, giving 110 microfarads at 600 volts. It's a way of getting a higher microfarad, because a 220 microfarad 500 volt capacitor is still, these days, quite a beast. And back then it certainly was quite a beast. In fact, there probably weren't any. So they put two in series. They put a balancing resistor across each to make sure that the voltage across each is the same. So these two resistors are in series. I don't know if you can see these are linked together here, look. So positive goes through here to negative. Right now, so that can go in there like so. That will squash in there like so. So I'm going to put some hot melt glue down on this one, but not on this one. Seems a bit random, I know. Now, have we got that right way around? Yes, we have. Positive. Solder that. Always checking my little diagram here. It's very irritating putting a capacitor in the wrong way around and realise you've got to swap it. It's okay. Now what we're doing up here. So again, this will go around here quite nicely. There we go, that's that soldered. Alright, now this one goes the other way, so positive goes up on that one. And I know we can put a bit of hot melt on that, good. We'll just put a bit down there. Whack that on there like that. Okay, so now all we've got actually is these 70 microfarads or 100 microfarads, I don't mind which, at 100 volts. I've got a feeling I've got some. Let me go and have a little look. Yes, indeed I do. I have loads of them. So that order I put in today wasn't really necessary, but it'll just top up my stock. Again, look at the size difference between these. Quite a big difference, isn't it? So 100 microfarads, 100 volts. These are 70 microfarads, 100 volts, so that's fine. So let's do these one at a time now as well. There we go. Legend uppermost, negative to the right, negative to the right, correct. There you go, that's that one in. Again, double check, negative to the right, negative to the right. So this one is positive to the right. So we'll chop this one out. Last one. Making short work of this. A little bit cracked, some of these capacitors here along the end there. Not sure if that's significant or not. Negative to the left. There you go. Right, so all we need to do now is a final, and I know they're correct, but I'm going to just double check again, make absolutely certain that everything's okay. So let's check. Positive, 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 positive upright, that's right, negative down. Positive down, yes. Positive up, yes. Positive down, yes. Sorry, I'm going by this diagram here. Positive to the right, yes. Positive to the left, yes. That's good. We're good to go now. I'm happy to turn the amp on once more and see if it works. Here we go, plug it in. If it's going to go bang, it's going to go bang now. Oh, sorry to disappoint you, but there's no horrible kaboom noises. It all seems to be working okay. Actually, I think that sounds a bit better as well with the new caps and the new valves. Always difficult to say, I know. But anyway, there you go. Actually, I think I'll just tweak this bias whilst I'm here. That's it. Oh yes, we can do that now, of course, because we've now got the new caps in. And in fact, oh, yeah, sorry, I should have showed that. Yeah, it is actually interesting. That, do you remember it was 32 or 33 or something? And I said to you, when we change the caps, we'll need to rebias. Now that shows you something actually. Here's a little fun thing for you. So it was about 30, 32, 33 milliamps. Now it's 28. And we have changed the capacitors which do the smoothing for the negative bias voltage, which means that these capacitors are better, and so we got more negative DC bias voltage, whereas the other capacitors were old and they weren't doing such a good smoothing job. So with more negative DC bias voltage, you get less current going through the valve. Remember, the more negative you make the grid, the more the current goes down. So that's exactly what happened. Very interesting. So now we'll turn this up to 35 or something. I might do a final bias. That's perfectly good enough. That good. Hey, we're doing well here. I'm gonna put this back on now. Then we can turn the amp upside down, and the only other thing to do is the low voltage 25 microfarad 25 volt electrolytics on the underside, and of course we have to service the pots. Okay, there's the top back on, and I always put a little label on there which says when the valves and the capacitors were changed. It's always incredibly useful, that. Wish more people would do that, because you get an amp and you don't know how old the valves are, or when they were last changed, or when the caps were done, so I always do that. Good, so we're now ready to flip the amp over. I think I'm going to have a little bit of a tidy up. This bench is getting very crowded, so I'll do that, and then we'll flip the amp over and have a look what's going on the underside. Right, here we go on the underside again. I've had a bit of a tidy up. It's a right old mess, my bench. And what we're going to do here is service the pots, but we're going to change all these electrolytic capacitors. Most of these are typically 25 at 25. Yep, that's what that is. I notice we've got a couple of 4 microfarads at 450 volts here. I'm not sure I've got any of those. Might have to order some. They're probably perfectly alright. But if we're going to change them, we may as well change them. Interesting switch arrangement here for this pull switch. Right, well, that's what we're going to do. We're going to make a start on changing these 25s at 25s. I'm just going to measure these screen resistors as well. They're carbon screen resistors here. It can be a bit of a pain if a screen resistor goes. So it should be 470 ohms, that's 520. So that's 10% out. They always go high, carbon resistors. Let's try this one, if I can get onto it. $650. That one's way out. Okay, I'm going to change both of those screen resistors. Won't be easy with this here, but I'll manage to do it somehow. And I don't like them right on the valve base like that, because they get hot, so I'm just going to take them a little bit to the side. Yeah, so I'll change both of those as well whilst I'm at it. No extra charge. I've done the pots, serviced the pots, so I'm going to call it a night now, and do a bit more on this tomorrow. Right, we'll have a go at one of these screen resistors here. See how I get on. It's not so easy doing it on camera because I can't stick my head in the amp, which is what I would normally do. And that actually came out quite well, that's good. Oh, right, well, that came off quite nicely. So just out of interest, let's measure out of circuit this 470 ohm. It's 520, so it's quite a bit out, look. Like 10% high, and I think if you remember the other one was even higher. So let's put a new one in. Tack that on for the moment. It's perfectly okay to tack something on with a soldering iron, and then of course you go over and do the joint properly later on. The other one's going to be more difficult, so I won't show you that on camera, just because I really probably will need to get my head in there. Okay, and that's mounted a bit kind of away from the valve, so that it doesn't get all the heat onto it. Now we can make these joints a bit better. and go over our tacked joint like so. So that's good. There we go, so one screen resistor done, and I'll pull the other one out and I'll show you what the measurement on it is. It's just a little bit awkward with all these wires here, so it won't be quite so straightforward as that one. Yep, that was considerably harder to get out, and here it is. So let's see what this one is. Look at that, 650, should be 470, so that's very high. So that resistor is, you know, 15% out or something. Yep, well, I'm glad we changed those. So I'll pop the other one back in there, and that's another little job done. I'm just waiting for some 4 microfarad at 450 volt capacitors in order to finish this job off. Fantastic, so there we go, 2 new screen resistors, and they both needed doing. I've measured the 1K5 grid stopper resistors here. That one's perfectly okay. Let me just remind myself about this one. And it is 1K5, very good, so that's spot on. Both of those were okay. There we go, so that's good. So we're done on this amp now, with the exception of changing these other electrolytics. So we're going to be changing 1, 2, 3, 4, 5, 6 25 microfarads at 25 volts. I guess we could do a couple of those, and then just waiting on these, and we're done. Well, the first thing to notice is that all the positives are down, so we don't need to worry about getting them right way up each time, or, you know, having to swap the polarity, I mean. So negatives are up, so let's start with this nearest one. I'm going to try and get these into the tag board this time, but you see there are 4 things in this tag board already, 4 connections going in, and 3 here, so it's often not that easy. That. There we go. These are 22 at 25 volts, but they're perfectly okay. Right, so let's see if we can get that into the tag board. If I can't, with the other ones, I'll use the same technique as I did on the big ones. Yeah, that went in okay. Good. Positive down, negative up, good. So that's fine. So looking like it's not too horrendous to put them into the tag board on this particular amp. Well, you don't want to watch me do all of these, so maybe we'll do one more. There you go, those 2 there, and those are the 1K5 cathode resistors on one of the preamp valves. So I'm going to go through the others now and change those. You'll notice, let me zoom out, you'll notice we've got exactly the same deal here. We have 3, in fact, 25 microfarad capacitors, and that they are across 1K5s, and that one's 680 ohms for reasons unknown, and they're all doing exactly the same thing, so that's good. We will change each one of those caps now. There you go, that's those 3 in. So all we have to do now is this little chappy over here, and when those come in we'll bung those in as well. Great, we're getting there. Okay, the 4 microfarads have come in. Actually they're 4.7 microfarads these days, which is fine at 450 volts. So those are going to replace these two here. So there's the size difference in caps. They're pretty much exactly the same length, but tiny diameter compared to the original. And I make it just one more. Just check positive to the left, positive to the left. And that was positive to the left. Yep, that's good. Got quite a big bag of bits here to give back to the customer. So just finally this one here, which is, just double check that's, yeah, 25 at 25 again there. Not particularly easy to get at with this black lead going across it. And there we go. So no, positive down, yeah, positive, 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 positive. That's all good. Right, you know what I'm going to do now, don't you? I'm going to turn it on again and just make sure everything's okay. Then we can, I think, put it back together. Call it a day. I think we're done on this. Alrighty, let's switch on. No horrible explosions yet. It's out of standby. Okay, well I'm happy with that. I'm going to put that back in the case now and call it a day on that one. Well, there you go, a Fender Concert from 1982-1983. Not an amp I've seen before. Quite an interesting amplifier, and the usual kind of things wrong with it. The electrolytic capacitors need changing, and a few resistors, and a revalve. And this one's good to go now for 25-30 years. Lovely amplifier, quite a beast to hulk around though, of course, which is always the problem with these. Anyway, I hope you enjoyed that bit of detail this time. You saw me doing a lot of soldering, and thanks as always for watching. I'll catch you again on the next video.